Getting into chapter 3, parallel and perpendicular lines. We're going to start off with pairs of lines and angle relationships. So we're going to start off with this thing called parallel lines. Parallel lines are two or more lines in the same plane that never intersect. So if we look here, we have line L, line M. They're in the same plane. They're never going to touch. So therefore, line L is parallel to line M. The symbol we typically use for that is we would say L is parallel to M, and that is that symbol there. Okay, you can have multiple lines that are parallel, but the key there is number one, they have to be in the same plane. Number two, they never are going to intersect. Skewed lines, two or more lines that are not in the same plane that never intersect. A easy way to think of this is if you think of a box. Okay, and we think of a plane like, let's say, the front here. Okay, so when you look at the front, if I wanted to focus in on this top, and I said to you, what is a line that is skewed to that? It would be this side or this back side because they're not in the same plane, but they're still never going to intersect. Okay, here in this picture, line J and line K. Line K is going through the plane, line J is flat on that plane. They're not in the same plane and they're never going to touch. Okay? Transversals, a line that intersects two or more lines in the same plane at different points. So if you look at this first drawing here, you have line L and line M, and it is intersected by transversal T. Okay, here over here we have line N, L, and line M, and again it is intersected by transversal T. Now, these two lines could be parallel or they don't have to be. So understand there are different rules that apply here. So the next part of this, we're going to talk about some theorems that are based simply on two parallel lines cut by a transversal or intersected by a transversal. Okay, so when we look at a transversal, we have some different labels here. So corresponding angles, if you want to think of it, they are in the same location, is how I kind of think of it, of the intersection. So for example, corresponding angles would be angle 1 and notice it's in the top left of that intersection. 5 is in the top left. So angle 1 and angle 5 would be corresponding. We have 3 in the bottom left with 7. So angle 3 and angle 7, they're both in the bottom left. We have 8 and 4. And we have 2 and 6. They are both in the top right part of the intersection. And that is corresponding angles. Okay. Next we have, the next one we have is alternate interior. The word alternate means across the transversal, but on the inside. So what I always like to think of is if you kind of draw a box between your two lines, here's your inside, and this is your outside of the box. So when we say alternate interiors, you would be thinking 3 goes to 5, or sorry, 4 goes to 5, and you have 3 to 6. And those are alternate interiors. The next one that we have is we have alternate exteriors. So alternate gets me across the transversal, but these are on the outside of the intersection. So 1 would go to 8, and then your other one would be 2 to 7. And those are your alternate exteriors on the outside, exterior, outside. Then you have this last one that we have, and that is consecutive interiors, also referred to as same side interiors. So again, if you think of your box here that's holding it up, so this is your inside. Consecutive interiors are the ones on the same side. So angle 3 and angle 5. And then you also have angle 4 and angle 6. And those would be your same side interiors. Okay, so now that we know what the angles are called, let's talk about some theorems that go with them. The first one that we have here is what is called the corresponding angle theorem. The corresponding angle theorem simply says, if two parallel lines are intersected by a transversal, then corresponding angles are congruent. So how do we know they're parallel? Well, this symbol here tells me that these two are parallel lines. Okay? So then we look who is corresponding. Well, you would know angle 1 is congruent to angle 5, top left to top left to top left. You have angle 2 is congruent to angle 6, top right to top right. You have angle 3 would be congruent to angle 7, bottom left. And then you have angle 4 congruent to angle 8, bottom right. Okay, so based off this line, they have to have parallel lines intersected by a transversal, then the corresponding angles are going to be congruent. Okay, the next one, we have alternate interior angle theorem. Again, it says if two parallel lines are intersected by the transversal, then the alternate interior angles are congruent. So again, alternate across the transversal, interior on the inside of the intersection. So this is going to tell me that angle 3 is congruent to angle 6. And you also know angle 4 is congruent to angle 5. And those are your alternate interior angles. Alternate exterior angles, again, parallel lines cut by a transversal, then your alternate exterior angles are going to be congruent. Remember, alternate across the transversal on the outside of the intersection. So angle 1 is going to be congruent to angle 8. And also you have angle 2 is congruent to angle 7. Alternate exterior angles. Okay? Our next theorem that we have is two parallel lines, the consecutive interior or same side interior angle theorem. Two parallel lines are intersected by that transversal again. Then the consecutive interior or same side interior are supplementary. So what that means is, again, these lines are parallel. So I'm going to look for my same side. So the measure of angle 3, or we're going to write it this way, angle 3 and angle 5 are supplementary. And then you also have angle 4 and angle 6 are supplementary based off of this theorem. All right, so now let's put it into practice. So the first thing I notice here is I notice that these two lines are parallel. So if you want to kind of think about it here, what that means to us is we're basically going to kind of divide this. We've got this transversal, we'll call that one T, We got this transversal, I'm just going to call it M, so we know the difference, okay? So I'm going to start up here on the two parallel lines cut by transversal T, and I'm going to move around this shape. Okay, so let's start in at 67. This is our given one. So from that, I need to find all those other angles. So the first thing I notice is that the 67-degree angle and the 6, those are consecutive angles. And since those lines are parallel, that means angle 6 also has to be 67 degrees. Alternate interiors, so the 67-degree angle and angle 5 are alternate interiors, and those would have to be 67 degrees as well. You also know that angle 2 would have to be 67 degrees two ways. It is vertical to the 67-degree angle, but it is also an alternate exterior to angle 6. Now, if we look for the other ones then, so on this other side, I need to figure out what angle 1 is. Well, angle 1 and angle 67 degrees are supplementary. So if I take angle 1 plus 67, that's going to equal 180. I'm going to minus my 67 from both sides. So the measure of angle 1 is going to give me 113 degrees. Now that I know that, then I also know that angle 3 is 113 degrees because they are vertical. I know this one and 4 has to be 113 degrees because they are alternate interiors. I also know angle 1 and angle 7 are alternate exteriors, which would also make it 113 degrees. Okay? All of that can be done because I have my two lines parallel cut by the transversal. Now, you'll notice I did not touch 8, 9, 10, 11, 12, 13, or 14 because they do not, the two lines T and M are not parallel, so those relationships don't abide there. So we basically treat this problem as two completely separate problems. So we come down to the bottom half here, the ones cut by the transversal M, and I start the process over. They give me the 115 degrees here. I know that angle 13 is 115 degrees because it is vertical. I also know that the measure of angle 14 plus the 115 equals 180. So if I minus my 115, then I know the measure of angle 14 is equal to 65 degrees because they have to be supplementary because they make a linear pair. I also know angle 12 is 65 because it is vertical. 14 and 8 are alternate exteriors, so I know that one has to be 65. I know 12 and 11 are alternate interiors, so I know that also has to be 65 degrees. Then if I look at the other ones here, 13 and 10, they are corresponding, so I know this has to be 115 degrees. And I also know the 115 and 9, those are corresponding, so that would also have to be 115 degrees. The object here is to use the things we know based off of the parallel lines cut by a transversal to find all of the missing sides. And that is how we're going to use those angle relationship theorems to prove different values.